All right, so I want to wrap up today's lesson with the following. We are talking about transforming the parent parabola. And when I say transforming, I'm actually referring to modifying, creating an offspring, a child, if you will. And so far, we've learned how to move it or shift it up or down, left or right. The mathematical term for shifting is called translation. So anytime you read a set of directions or you hear the word to translate in mathematics, it does not mean to convert it to Spanish. Terrible joke, sorry. It means to shift, okay? So a translation of a graph is a shift, vertically up, down, or you could have a horizontal translation left, right. Just to quickly emphasize, when you want to shift horizontally, it's opposite your intuition. You're going to go inside the group, and to move right, you use subtraction. To move left, you use addition. The final transformation is not a shift. We're not going to talk about shifting a graph, but what we call it is stretching or shrinking a graph. This is our last transformation. So if you've been following along, we're wrapping it up right here. A stretch of a parabola means we multiply x squared by a factor. So in this case, I'm sorry, to stretch it has to be a factor greater than 1. So let's look at 3x squared. 3x squared. So what does it mean to stretch a graph? Literally think of like a rubber band, all right? You can look at what you're at the blue parabola and notice that one point did not move. That's the vertex. The vertex is locked in place. Every other point moved, but we can't call it a shift, right? If you literally think about shifting, everything has to move up, but the vertex didn't. So we call this instead a stretch for obvious reasons. When you look at it, it looks like the parabola got stretched, all right? A shrink is when you multiply by a factor between 0 and 1. So for instance, 0.5. Now, again, comparing the parent parabola to 0.5 of the parent parabola, 0.5x squared, the graph now appears a bit wider than the parent, okay? So I don't know why we don't call it a stretch or a widening, but I don't get to create the rules. It's called either a stretch or a shrink. So we say that this graph has shrunk by a factor of 0.5, right? So to emphasize the main point here, if you multiply by a number greater than 1, like 6, you stretch. Like 8, you stretch it. And the greater the factor, well, the greater the factor, the more stretched it becomes. All right, which just means it looks narrower and narrower and narrower, but the vertex remains locked in place. Now, if you multiply by a number between 0 and 1, like 0.1 or 0.2, oops, or 0.9, hey, now I'm getting lost in my work here. 0.9, you can't really see it. Right, 0.9 is pretty close to 1, and we know multiplying by 1 doesn't change anything. So 0.9, pretty close, but you can see that if I zoom in here, it is, I can't really zoom in. Oh, it is. It's a little bit underneath that parent function, right? So we'll stick with, now I'm totally lost in my place. We'll stick with nicer values, meaning something more like 0.5, so you can really kind of emphasize what's going on, or 0.4, as I showed before. And one thing I'll just emphasize, the closer you get to 0, the wider the graph looks. And by the way, we don't have to just use 0.1. We could use 0.01. And now it doesn't even resemble a parabola anymore. We'd have to zoom way out to kind of see that U shape, right? To get some perspective there. But that's multiplying by a factor of 0.01. Now again, the black parabola is the parent. This 0.01x squared is some offspring. It's a shrink. That's what we call it. Good old IXL. You knew this was coming at some point. So at this point, you're going to practice some of your skills. You don't have to submit any other work thus far. But what I want to look at is applying transformations of parabolas. So we're going to go to Algebra 2. I'll have this link right in the Google Classroom for you, so you won't even have to do all this work. But the title is called Transformations of Quadratic Functions. The search code is KQL. And let me just start off by saying that this expression right here looks really intimidating, but let's break it up into parts. This number A is it multiplying a group, and then there's a number at the end that's being added to the group. What was today's lesson about? This multiplier, the A, will either stretch or shrink the parabola. Let's break it up into this part, the actual grouping. And we have a number inside the group, inside the parentheses. Well, we know that's a shift or a translation left or right, opposite of what we think. The number at the end, what is marked as K, is also a translation, but it's vertical, either up or down. So I'm going to work through a couple of these with you. This video is going to go a little bit longer than I like to, but I want to work through a couple of them with you. It says, translate the graph 4 units down. So how do we translate the parent parabola, the parent quadratic 4 units down? We keep x squared. I don't know why that got zoomed like this. And to shift 4 units down, we subtract 4. Done. Okay. Translate, again, that just means to shift the parabola 10 units to the right. Ooh, right is horizontal. I need to go inside a group, inside opposite. So normally I would think moving to the right means to add 10, but I'm going to open up my group. I'm going to write minus 10 inside the group. I'm going to write minus 10, not 109 there, and then square the group. See the difference there? Inside, we'll translate it, we'll shift it left or right, and inside opposite. It's a nice little phrase, inside opposite. Just got to remember that's your horizontal effect. Submit, good to go. Oh, a reflection over the x-axis. I forgot to go over that. Here's a hint. You're watching the video now. You just multiply. Which one of these is a multiplier? A. A is a multiplier. Aha. So a reflection over the x-axis, you're going to multiply by -1. I forgot to add that in the exploration on Desmos, but I'll do that for tomorrow. So paying attention when you have to multiply across the x-axis, multiply by a -1. So we're just going to write negative. Okay. X squared, right? I didn't put the 1 because 1 can be invisible, but I did put the negative sign so you can see it. Yeah, I'm glad that came up. Translate 3 units left and 9 units down. All right, multiple transformations here. So inside the group, left, I would think is a minus. Inside opposite though. So I'm going to add 3. All right, we're back. I think we had a little bit of technical difficulties there. So let me get myself back. So we're going to translate 3 units left and 9 units down. Plus 3 inside the group. Minus 9 outside of it. Now we have multiple transformations going on. Good work. Let me see. If I can jump ahead a tiny bit here. Now this asks you to write the function rule for g of x. Okay. So what do you notice here? Well, I noticed that the vertex is no longer at 0, 0. Where is it? It's at 0, 6. So describe in words how to move from 0, 0 to 0, 6 in the simplest way. You go up 6. Oh, that's all. So I would just write this as x squared plus 6. End of story. Keep it simple. And once you get to a smart score level of 70 today, you can stop. All right. So that's it for today. This video is at 11 minutes, so I'm going to stop here. If you are stuck, you know how to reach me. But if you don't, email me, MRODOLEWICZ@cpsed.net. Or you can post a comment right on Google Classroom, and I will be available to respond back to you throughout the day. Have a good afternoon with all your courses. Make sure you submit your attendance. Make sure you're keeping up with the classwork, and make sure you are taking time to wash those hands.